Hey guys, it's Miss Johnson, and I'm here to bring you our notes for Unit 1 Notes 2, which is on measures of central tendency. When we talk about measures of central tendency of a data set, we are talking about the values that tell us approximately where the middle of the data set is. And there's a bunch of different ways to consider the middle. Do we consider it if the data is in order? Do we consider it like an average or a mean? So there's a lot of different ways that you can evaluate or determine what the center of a data set is. One of those ways is a really common way that we've been using all the time since you were young kids. The mean, the arithmetic mean. Some people call this the average. The mean is just the sum of the data points divided by the number of the data points. And this is the most common mean that is used all the time. It's the same mean that is used to calculate your grades. It's the same mean that's used to calculate your GPA. It's the same mean that it's used all over the place. One thing that we want to get in the habit of doing in statistics is using the round-off rule. When we use the round-off rule, we look at data, we look at our data set, and then when we calculate our statistics, so if I'm calculating the mean, I'm going to round my mean one decimal place beyond whatever my data set was. So if my data was all whole numbers, then I'm going to round my mean to the nearest tenths place. So when you hear in news media and stuff, people will say things like, they'll say things like the average American household has 2.5 kids. Obviously, you can't have 2.5 kids. You either have 2 kids or you have 3 kids. What they're using is the round-off rule there. They're rounding it one decimal place beyond what all the data is. All the data is whole numbers. You have 1 kid, you have 2 kids, you have 5 kids, you have 7 kids, you have 3 kids, whatever it is. And then when they calculate the mean, they round it to the tenths place because that's one decimal place beyond the whole number that they started with. We're going to take just a minute here to review some rules of rounding. If I can get my slide to turn. We're just going to do some rounding reminders here and just refresh our memory on what decimal places are where. I like using purple. So if I'm looking at this first number 3.4283 and I want to round it to the hundredths place, the hundredths place is the second decimal place after the decimal point. What that means is I need to look at the thousandths place to round the 2, and the thousandths place is an 8, so that's going to tell me to go up. I round it to 3.43. If I look at this next one, I have 126,738,003, and I want to round it to the 100,000ths place. The 100,000ths place is right there. Again, that means I'm going to look at the 3, the one that's behind it, to round to that. So that becomes 126,700,000. 3 tells me to stay down, so I don't increase that 7. The thousandths place, remember that THS at the end means that you're behind the decimal point. So 24.823027. I want to look at the thousandths place. So this is the tenths, this is the hundredths, this is the thousandths. So I need to look at that 0 and round to the 3. And I'm going to keep it the same. So 24.823 there. And millions, in the last one, I have 34,925,682. This is something I like to think about news media again with an example like this. You'll hear a lot, that, Oprah Winfrey's worth is $72 million. Is it exactly $72 million? No, it's not exactly $72 million. It could be $71,968,000. But they're not going to put that in a news article because that's a mouthful to say, and it's a moot point at that point. It doesn't matter. Those nitty-gritty details don't matter that much. So when you're thinking of something like 34,925,000 blah 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 blah, that's a long number to say. They're going to look at this 9 and they're going to round that up and call that 35 million. Okay, so rounding is obviously a practice that's used all the time, every day, all over the place. Some other measures of central tendency that we look at are median and mode. These are 2 that you're probably familiar with. Median is the middle point of an ordered data set. I like to think of this as what's the median of a highway? You've got your lanes on one, and then you've got this middle part where you've got, maybe some trees or just some grass or whatever, or maybe sometimes it's paved. Then you've got the other lane on the other side. This part right here is called the median. It's called the median because it's in the middle. That's the same thing for the median of a data set. The median of the data set is the middle point of an ordered set of data. That's the important thing there, is that it's an ordered set of data, okay? It's not just any set of data. You have to make sure those data sets are in order. If it happens that there are 2 points in the middle. If you have a data set that has an even number of points, you're not going to have a middle value. Since you can't have a middle value there, you're going to average the 2 that are in the middle. So you find the mean of those 2, or in other words, add them up. You've got one number plus the other number and then divide it by 2. Mode is the data set that appears most often. Let me get some of this stuff out of your way. Figure out how to use my eraser here. Whoop. Maybe. Okay, we'll just do that. This is one of my first times using this software to record videos, so I'm learning. Okay, so the mode. The mode is the data point that appears most often. You see that data point the most. A lot of people argue that mode should be the reference for grades. Mode should be the measurement that we use to calculate your grades. For example, there's typically 7 tests in probability and statistics. When we get to the end of 7 tests, if you are a person who has 6 B's and 1 D, that 1 D might be enough that it brings you down to like a C+. But does that mean you're a C+ student? Not necessarily. If you had 6 B's and you just came in and had an off day and you got a not so great score on one of your tests, should it punish you as much? Or should we be using the mode, which is the fact that you earned a bunch of B's, so you're kind of a B student, okay? So think about it that way. That's what a lot of people argue should happen with grades, just because of those factors. You never know when somebody's having an off day or, things like that. So it is possible to have no mode at all. It's also possible to have more than one mode. So that just depends on the data set you're looking at. All right, the last one that we're going to talk about for measures of central tendency, and then we'll do an example with a couple of these, but mid-range. This is one that you maybe have never heard before. So the mid-range is the value that's midway between the highest and the lowest. It's literally the middle of the range. If you think of the range of a data set, the range of a data set was the highest minus the lowest. Okay, so when we want to define the range, that we're asked, how far does the data span? What's the span of the data? How wide is our data set? If you're finding the middle of the range, you're taking the highest plus the lowest and dividing it by 2. You're literally averaging the range, okay? So that's one. It's a really easy calculation. Obviously, we all know how to add things and divide them by 2, but for some reason, it's like hard to get it stuck in your head. So it's not range where you're subtracting the 2. It's the middle of the range where you add the 2 and then divide by 2. Cut them in half. Cut the range in half. So add them and divide by 2. All right, so let's take a look, and we're going to do a few examples here. If you don't already have your calculator out, now's a good time to grab your calculator, and then actually, I need to go grab mine. All right, so if you've got your calculator, grab it, use it. We're going to work on some things together. So we're going to find the mean, median, mode, and mid-range of these 3 data sets. I'm going to start in A. So mean, if I'm going to find the mean, the first thing that I need to do is I need to add all of these up. The other thing that you need to find for all of these data sets, because you're going to need to know it, is that thing that we talked about yesterday that you're going to have to find every day. How many points are there? So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My n is 10 here. And then I need to find the sum. So one symbol, if you if we haven't talked about this symbol yet, which I don't think we did yesterday, a symbol that you're going to see quite frequently in this class is this symbol. This is capital sigma. It looks kind of like that funky E. It's a Greek letter sigma, and that symbol means sum. If you ever are looking at an Excel spreadsheet or something, the formula symbol for sum is this capital letter sigma. So you'll see sigma quite a bit. So if I find the sum here, the sum of these points, I'm going to type them into my calculator. 3 plus 3 plus 4 plus 5 plus 5 plus 5 plus 6 plus 7 plus 8 plus 9. I have a sum of 55. So if I take the mean is going to be 55 divided by 10, because that's the sum of the data divided by the number of points, which is 5.5. Now, the round off rule tells me that I need to round it one decimal place beyond the data, and my data is all whole numbers here. My mean goes out to the 10th place, and it terminates there. So I don't actually need to do any rounding here. I'm okay leaving it where it is. Okay, so we have calculated the mean. We have a mean of 5.5. Now let's do the median. So if I'm going to look at the median of this data set, that means I need to make sure the data set is in order. And when I look from start to finish, it is 3, 3, 4, 5, 5, 5, 6, 7, 8, 9. So I have an even number of digits here. The middle of my data set is going to be between the 5th and the 6th digit. And you can even just do the good old-fashioned, like, cross them off from the outside. Cross off, cross off, cross off. And you're between 5 and 5, which in this case, technically that would be 5 plus 5 divided by 2, but we all know what's going to happen here. That's just 10 over 2, which is still 5. Okay, so our median is also 5. Go back to red here. My mean is 5.5. Now let's look at the mode. The mode in this case is the one that appears the most. Here, let me clear this off a little bit so we can see a little better. And my mode here is going to be the one that appears the most, which 5 is the one that appears 3 times, which is the most. So my mode is 5. Okay, erased my little box. There's that one. And the mid-range. The mid-range is, again, that new one that you guys probably haven't done before. So my mid-range is going to be the lowest plus the highest divided by 2. So that's 3 plus 9 over 2, 12 over 2, which is 6. Hopefully you guys can see that outside of my range there. I think you can, outside of my little window. So, so the mid-range is equal to 6, just in case it cut off there. All right, so if I look at my measures of central tendency, they're all fairly close to each other. 2 of them are even the same, but they're not all identical. And that's where it depends on what kind of data you're looking at, what it's representing. There's a reason to pick different measures of central tendency to mark the quote-unquote middle of your data. So let's take a look at part B. In part B, the first thing that I notice is that my data is not in order. So I'm going to take care of that first. I'm going to rearrange my data set and I'm going to put it in order. I have 1, then 2, then it looks like 4, then looks like 5. So 1, 2, 4, 5, 8, then 15, then 17, and then 35. Okay, so hopefully you can read that okay. But there's my data. If I go through and I count them, I can see that I have my back on blue. 1, 2, 3, 4, 5, 6, 7, 8. My N is 8 there. The other thing that I have to do, because I know I'm going to need it for mean, is find the sum. So again, grab your calculator and add them up. 1 plus 2 plus 4 plus 5 plus 8 plus 15 plus 17 plus 35. And I've got 87. So my sum here is 87. All right, so now I can go through all of my points here. My mean is going to be 87 over 8. And when I take 87 and divide it by 8, I end up with 10.875. So 10.875. However, I want to use the round off rule here. So my data, once again, is all whole numbers. So I'm going to use I'm going to need to round to that 8. I'm going to need to round to the 10th place. So I'm going to use the 7 to decide what to do with the 8, which is going to become 10.9. So that's my mean. If I take a look at the median, I have 8 digits here, so it's going to be between the 4th and the 5th. So I'm at 1, 2, 4, 5, and 8. I'm between the 5 and the 8. And again, you can do the good old-fashioned cross-off, where you cross off the 1 and the 35, cross off the 2 and the 17, cross off the 4 and the 15, and then you're between 5 and 8. So my median is, just switched colors there, is equal to 5 plus 8 divided by 2. That's 13 over 2, which is 6.5. So there's that one. If I go to mode and I look for what appears most here, all of my digits are unique. All of my data points are different. So 1, 2, 4, 5, 8, 15, 17, 35. They're all different. So that means I'm going to end up with no mode here. There's no mode in this data set. And then mid-range, the mid-range is that highest plus lowest, 1 plus 35 divided by 2. That's 36 over 2, which is then equal to 18. All right, so take a look at our measures of central tendency here. We have a mean of 10.9, a median of 6.5, a mid-range of 18, and no mode. Weird. This is a really weird data set. So think about what could have happened in this data set to give you such different looking data. Your data is really unique here. If I look at the order of my data, 1, 2, 4, 5, 8, those are all pretty close to each other. Then so my jump from 1 to 8 is 7 places. My jump from 8 to the very next point is another 7 places. When I go from 8 to 15, I go 7 places. Then I go 15 to 17, 17 to 35. My jump from 17 to 35 is bigger than my jump from 1 to 17. The whole rest of the data set has a range that is less than the split between the 17 and the 35. That tells you something. This 35, if we did this in a box and whisker plot, this 35 would probably be considered an outlier, which means we probably shouldn't actually consider it as part of our data set, and then we would recalculate our statistics. But that's what gave us 3 very different, we've got 3 very different measurements here, and with no mode to boot. So we have no way of really getting an accurate picture of the middle, because they're all very different, because our data set is very unique and has some interesting patterns in it. All right, one more round that we're going to do this for. We have 3.2, 2.7, 4.9, 3.8, 5.6, 6.2, 7.7. So the first thing, again, I'm going to take this data set and I'm going to list it in order. It looks like my lowest point is 2.7. So 2.7 is going to come first. I don't have any more 2s. So then I have 3.2. Then I have 3.8. Then I have 4.9. Then 5.6. Then 6.2. And 7.7. All right, so if I go through here and count my number of data points, 1, 2, 3, 4, 5, 6, 7, my n is equal to 7. If I add them up, grab your calculator and add them up, 2.7 plus 3.2 plus 3.8 plus 4.9 plus 5.6 plus 6.2 plus 7.7. 34.1 is what I get for a total there. So my sum is 34.1. So now I can use that to find the mean. And when I find the mean, I've got, I've got 34.1 divided by the 7. So 34.1 divided by 7 gives me 4.871. 4.87142, blah, blah, blah. It keeps going and going forever as far as I know. I'm not really sure where it stops. My data here, let's talk about the round off rule. All of my data, it goes out to the 10th place. So, and none of them go out to the hundredths place, so I don't need to worry about one more. But what that means is that I'm going to round to the hundredths place, because again, the round off rule tells us to go one digit beyond our data. So I want to round to the 7. That means I need to look at the 4, or look at the 1 to decide what to do with the 7, which means it's going to stay the same. So my mean here is 4.87. Okay, so there's that. Now let's go on to median. So median, I have a true median here because I have 7 digits. I have 7 data points. And whenever you have an odd number of data points, you can get a true middle. So if my middle is going to be the 4th data point, I'm going to be able to get rid of 3 on either side. And then my median is that 4.9, which is in the middle. Great. All right, let's look at the mode. My mode, are there any that are the same here? The farther out your decimal goes, the harder it is to have 2 that are the same. 2.7, 3.2, 3.8, 4.9, 5.6, 6.2. There's no mode here. None of them are exactly identical. So we'll have to consider that. And then last but not least, let's find the mid-range. So for mid-range, I need the highest plus the lowest. That's 2.7 plus 7.7 divided by 2. 2.7 plus 7.7 is 10.4. 10.4 divided by 2 is going to be 5.2. So my mid-range is 5.2. So this data set is a little bit more symmetrical. It's a little bit more closer together. There's not any weird patterns. There's not any weird gaps. Like up here, we had the weird gap between the 8 and the 15. Then we had that really big gap between the 17 and the 35. This was a pretty less predictable data set. This one's more predictable. I go from 2.7 to 7.7 and everything's pretty evenly spaced out in the middle, which is why you end up with measures of central tendency that are so close to each other. 4.9, 4.87, 5.2, those are all really close. All right. So the last thing that we're going to do is we're going to talk about how to calculate this based on some test scores and if we have things that are missing. So in example 3, it says Lexi earned the following test scores this trimester: 68, 70, 75, 75, and 90. Use the data to answer the following questions. So part A says, what score does Lexi need on test 6 so that she has a mean score of 77, okay? This is what we want the mean to be. If I haven't showed you this already, I apologize, I just threw that out to you, but let's look at this little symbol here. X bar is the notation for the word mean. So you're going to see X with a bar over it quite a bit in this class, but that notation is the notation for mean. So we want X bar to be 77. We want the mean to be 77. So what that means is think about what we have here. We have a mean that is equal to 6 test scores. We know 5 of them: 68 plus 70 plus 75 plus another 75 plus 90. That's 1, 2, 3, 4, 5 of them, plus a score we don't know. We don't know the last score. All of those scores are going to get divided by 6 because there's 6 tests, and we want that answer to be 77. Okay, that's our formula. That's the setup here. We have this missing test score right here. This X is the one we don't know. That's our question. What does that last test need to be? And this is a question I get all the time from all classes, all grades, all levels. What do I need to get on the final to keep a B? What do we need on the next test to go up to an A? People ask me that question all the time. So here's how you find it out. So the first thing that I'm going to do is I'm going to take these 5 test scores and I'm going to add them up because I can combine those. I know what those are, so I'm just going to go ahead and add them. So 68 plus 70 plus 75 plus another 75 plus a 90. I end up with 378. So I get X bar is equal to 378 plus X over 6 equals that 77. I apologize, I don't have a whole lot of room for you to show some work here, so I'm kind of cramming stuff in. But now if I look at this formula as it stands right now, the next thing that I need to do in order to get this x by itself, by the way, I'm using good old algebra. Algebra, your friend, algebra that is really important, that we told you for years is really important, that you need to be able to use. Here it is. So I'm backing myself out of this equation to solve for the unknown, which is the actual definition of algebra. All right, so the next thing I need to do to solve for x is get rid of this 6. This 6 is being divided, which means I need to multiply by 6 over here. Because if I multiply by 6 on both sides, that cancels out. Remember that whole game? Balancing, multiplying something, on doing whatever you do on the left, you have to do on the right, all of that. So 77 times 6 gives me 462. So I have 378 plus x equals 462. Last but not least, undo the 378. Remember all of this? Minus 378. And I end up with 462 minus 378. A score of 84. So x equals 84. That tells you that she needs to get an 84 on her next test to end up with a 77% or a 77 in the class. All right, let's take a look at part B. Now I'm looking at the median. What score does Lexi need on test 6 so that the median is 74? All right, let's look at the 5 tests that she has. She has a 68, she has a 70, she has a 75, a 75, and a 90. Okay, so the 6th test, again, we'll call it X, has to go somewhere. It needs to go somewhere in this set of data, okay? Let's talk about where she wants the median to be. She wants the median to be right here, okay? That's where she wants it. So she has 1, 2, 3 test scores above it and 2 test scores below it. So if this is a true median, that means that it has an equal number of data points on either side. So test X, that we don't know yet, is going to have to come over here. Because I already have 3 data points on the right-hand side, I'm going to need a 3rd data point on the left-hand side of this 74, which is my goal. Okay, so then the next thing is the median needs to be equal distance from the 2 points around it. Well, the median is only 1 digit away from the point to the point right above it. The median that I want is a 74. Since the median that I want is a 74 and the point right above it is a 75, that tells me that the score that I need to balance her out is going to be a 73. It's 1 digit away from the 74 in the other direction. If she gets a 73, now the scores look like this: 68, 70, 73, 75, 75, and 90. And then if you put the median in there, it would be between the 73 and the 75, which is a 74. Okay, so I figured out that I needed a 3rd point to the left of the median to balance that out. And then I figured out that I needed it to be only 1 digit away from the median that I want because the other side was only 1 digit away. So the X that I have here, the score that she needs, is a 73. All right, next one. What score does Lexi need on test 6 so that the median is 75? So again, let's start with the data we know. We have a 68, we have a 70, we have a 75, we have a 75, and we have a 90. So again, we're looking for test number 6. Where does it go? And this time, she wants a median of 75. Well, the beauty of this is that her median is already 75. She's between a 75 and a 75. However, she's got 2 points over here and only 1 point up here, which means that her test score needs to be on the right-hand side of this median. So it needs to come up here. Okay. But really, it doesn't matter. It could be 75 and the median would still stay 75. It could be 76, it could be 78, it could be 90, it could be 99. It could be 99 and her median would still be 75. It doesn't matter which score she gets as long as it's above 75. So any score, and not even above, it could be 75. 75 or above will give her that median. Oops, no R there. 75 or above. Okay. All right, last part, and there's not a lot of space here, so I'll try to squeeze it in. What score does Lexi need on test 6 so that the mode is 75? This is another one that's kind of a funny way of thinking because 68, 70, 75, 75, and 90. And once again, her mode is already 75, okay? So the question is, what is the last test score need to be so that her mode stays 75? The real answer here is we don't want a mode of 68 and we don't want a mode of 70 and we don't want a mode of 90. We only want the mode of 75. So she can get any test score, any score from 0 all the way up to 100 except for these 3. Because if she gets another 68, then it's also a mode with the 75, and that's not what we want. If she gets another 70, then it's also a mode with 75. That's not what we want. If she gets another 90, it's also a mode with the 75, and that's not what we want. So that's the true answer here. The true answer here is any score except the 68, 70, or 90. So... all right, that takes us to the ends of our slides here. Thanks for listening to the notes video for today. Let me know if you have any questions. Go ahead and work on your practice assignment, and I will catch you next time.